Hello guys, I decided to move on to the excavator PCB instead of making another vehicle PCB for the Fendt 936. So what I'm going to do is give you a little look at this PCB, and then I'm going to temporarily put it into the PC400, the Komatsu PC400, because I don't have the final motor driver here. I'm going to have to take it out later to finish it off. So, like you've seen in one of the previous videos, this PCB is pretty much the same as the vehicle PCB. We have our Atmega chip, which is controlling two PC400LC IO expansion chips, and that then going to three motor drivers, TB6612FNG motor drivers. So it's basically the same idea, only we have more motor drivers because we need to control all the different functions of our excavator, or all the different screw drives really is what I mean. So I've made this one up here. I have my NRF radio module there, and if I give it some power here, I have 7.4 volts here on this battery, and bring in my motor here again. I'm having problem with some of the pins because I ran out of PWM pins, because a lot of PWM pins are actually being used by the NRF 24 radio module, so we're kind of limited there. So what I tried to do was I set up the digital pins. So I think the pins controlling the PWM for the motors are 2, 3, 4, 5, 6 and 7, but only pins 3, 5 and 6 are actual PWM pins. So my plan had been to use a software library that created PWM pins using the normal digital output pins, but that's not working so good at the minute. It seems to be doing a PWM at about 1 Hertz, which isn't really working at all for me. So I'm going to have to try and figure out how to get that working at a later stage, but for the time being we do have a few PWM pins working. So the first one here is pin 2, and that's just one of the software pins. So you'll see that the motor turns on and off pretty slowly, rather than the PWM should be turning the motor on and off really fast, so that you can't see the off period. You only see the motor ramping up in speed and ramping down. You can see here it's on for a small period, off for quite a long period, and if I go to full throttle, it's on for a long time and off for a small period. So obviously the PWM isn't working there. This should be pin 5, so it's a hardware PWM, and you should see the motor ramp up in speed as I move the throttle forward. So you see the hardware PWM pin works perfectly fine. Other than the PWM pins, I have lots of analog inputs and a couple of outputs, a few here from the PC400LC chips, just 3 leftover pins. But there's also the analog inputs there that we can do some sort of feedback from our controls. This is only kind of half working for me with the software PWM, but I want to use this model during the weekend, so I'm going to wire these up and change the normal digital pins back to just normal digital pins. I'll remove the software serial. That should let me use pin 3, because the software serial knocks out pin 3 because it's using the same timer, but it's obviously it's not working. It's not much use to me. So what I'll do is get rid of the software serial and put the normal pins back, so the screw drives will just come on full speed. And that will do for a little show that I'm going to the weekend. I just want to kind of demonstrate the model a little bit at least. I will have proportional control on the slewing and one of the boom motions, so that'll be enough. The slew going at full speed wouldn't work at all, but the other screw drives, they should be alright. I'm going to keep the voltage down at 7.4 volts. The model works much better at 12 volts. It's more realistic speed, but if I have to go full throttle all the time, it'd be better to leave the voltage down a little bit for the time being. I have another problem to deal with on the PC400 before I can really get the electronics properly mounted in. You can see here that the weight of the boom really pulls the model forward, so when the motor tries to push, it kind of flexes its own mounting a little bit, and that's enough that the gear can slip then. So what I really need is a counterweight on the back here, and it doesn't have to push it down very far, it just has to be enough to keep it level so that the gear won't slip even when it's pushing. So you mightn't be able to hear it, but when I hold it like this, the way it is, the gear can just spin around the outside of that's the gear of the motor can spin around the outside of the larger gear. But if we just level off the base, and even when we push on the gear to push it out, or push on the motor to push the smaller gear out, it won't disengage from the larger gear. So I need a weight on the back of the model here. So my solution to this is pretty simple. All I have is some scraps of roofing lead here that I just cut up, and I'm going to hot glue them in place there on the back, and with any luck that'll be enough just to keep the back down. If it's not, I might need to add extra weight on the back outside the back of the model, because the further out you go the more leverage you get, obviously. So because we need space in here for the electronics and the batteries and all of that kind of stuff, we might need to add some extra weight on the outside, which if we do it right shouldn't look too bad, because there are some excavators out there that would have extra weights, and they normally have longer booms though, so we'll just have to see how it turns out. Also, I'm going to need to remove these legs here, so I'll cut these off and just hot glue the mounting points here. You can see it, they've kind of got guide holes that meet with a pin in the die cast body, so I'm just going to hot glue them in when I remove this part, because I need all this space for the battery. I think is going here, and the other electronics is going over here, and these things are just pushing down in the way, so I need to remove those. Here's the end result with the lead. I've just coated it with the hot glue there, and as you can see the PCB is in place here, all wired up to everything. I have the wires from the tracks just kind of flapping around there, they're not being used at the minute, so this just sits down on top here and puts a little bit of weight on it, and as long as the gear on the on this motor for the slewing mechanism, as long as it's tight up on the motor, because it's only a press fit, and after a lot of spinning around there and a lot of jostling, as the excavator is going to put a lot of weight on the boom as it's extending it and pulling really hard, so it might move the gear slightly on this, but as long as when I'm getting set up to use the model, I just tighten up the gear on the slew mechanism, it works pretty good now. I had it over at the Tullivin Fair and it was working pretty well. Well, at the start the gear wasn't tightened because I didn't know I had to do that, so I was finding that it was having trouble slewing, but once I figured out that it was just that gear was a bit loose, I pushed that tight and then it seems to work pretty good. There's not much to see in here really. The radio module is coming up in under the seat of the cab here. The wires for the motors are connected here for the boom and the slew, and like I said, the tracks, I didn't do that yet. In the last few videos you would have seen it at the Tullivin Fair, so it's obviously working okay. I probably want to put some feedback in the boom to stop the motors overextending the little screw mechanisms and breaking them, but I didn't have that trouble at the fair. So that's all I have to show you today. If you liked the video, make sure and hit the like button, and if you have any comments, leave them below the video or head over to the forum, and that's pretty much everything. So thanks very much for watching.